So in last lecture we have seen this explicit type conversion. So implicit, that is the automatic type conversion, and sometimes we need our not we didn't get our expected output in the format. So we are using the explicit type conversion. So we have already seen in one example of the float. Next, we have see the bitwise operator. Bitwise operator is performing tasks on the bits. So bitwise operator will not modify the operand, and bitwise operator are not applicable to the real numbers like for float and double. It is not possible to apply it. So this is the truth table of the bitwise and or XOR and complement. So whenever you do complement, at that time you have to see your number is in the format of signed or unsigned, and if it is in the unsigned format, number will be in the negative. Next, we have seen the conditional operator. So conditional operator is a ternary operator and it needs three operand to perform tasks. So conditional operator generally is like a if else condition. Suppose this my expression, this my condition will become true, then this expression will do perform task. If this expression will become false, then this expression will perform task. Using bitwise operator, we have to find number is even or odd. So how we can find using bitwise operator? Number ending with 1. Suppose my number is 3, 1 1 0 0, and I will do ending operation with 1. So in odd number, always my this sign will be 1. Because of that reason, I am doing ending with 1. Suppose this is 1, my output will get 1. At the time, I can say this is the 0. So here it will give 0 0 0 0. This number is odd. Suppose my number is 10, so 1 0 1 0, and I will do ending with. So now my output is 0 0 0 0. So I will say this is even. So I will write down here, copy this line code, number ending with 1 is equal to 0. Then I can say my number is even. If this is not 0, then my number is odd. Mm, Number ending with 1 is equal to 0. Here in that without bracket, it is first comparing with 1 is equal to 0, and then after doing ending operation with I. So parenthesis is important. So this is your homework. Write a program to check given number is power of 2 or not using bitwise operator. Next is shift operator. So in shift operator we have two things. One is the left shift and another one is the right shift. So shift operator consider as a bitwise operator. Shift operator are binary operator. So it needs two operand to perform task. Shift operator are binary operator. So it's need two operand to perform task. So it's left shifted and right shifted. Like this way. Here something, here something. Shift operator will not modify the operands. So this number also, this operator also not applicable to real numbers. Then suppose I will write k is equal to I left shifted by j. So how we need to speak I left shifted by j times. That means first operand is shifted to second operand times. For example, I will take here I is equal to 10, j is equal to 2 and k. K is equal to I left shifted by j times. That means 10 lap shifted by 2 times. So here first we need to convert 10 into the binary because shift operator is also bitwise operator. So we need to convert into the binary. So binary is 1010, then 0000. I am taking the 1 byte only. Okay. So then I will do 10 lap shifted by 2 times. So in first time what happened? Every bits is lap shifted by 1 time. So this 0 will come here. So I will draw like this. This 0 will come here. And this one will come here. And this 0 will come here. And here 1 0 will added. So this is my happen lap shifted by first time. So this is my 10. Next lap shifted by second time. This 0 will come here. This 0 will come here. And here 0. This 0 will come. And next 1 0 added. So this is my output. This both 0 will go outside. It will not usable more. So my output is here, my input is 10, and once I will do I lap shifted by 2 times, my output is this one. So what is this? This is 40. So I get here inside the K for 0 as output. So one more time, 10 is lap shifted by 2. That means you have to write down first binary of the 10, and you have to do first time one lap shifted. So 1111 things will come here, and here 10 will added. Then again next time 1 step ahead at the left side, and here one more 0 will added. Suppose you have a 4 byte, so you have a 32 bit will shift here, and most significant bit will go to the outside. It will not usable. Suppose I will do this is the 5 times here. So this 0 will come here, this 0 next third, fourth cycle, fifth cycle, this 1 will go outside. So like that way. Here 2 times. So we will see one more example with. So write down this in your book. Okay. So next is the right shift. So right shift I will do K is equal to I right shifted by J times. That means here my 0 0 0 0 1 0 1 0.
Yogin, one more question. So, like if the for the previous example we took it by two, so it was a small number. In case we are left shifting or right shifting a greater number of values, then will we have to shift every time that I mean that much times we will have to shift the perform the function.
Yes, exactly.
Okay.
Suppose you have a number of 1000, so you have to convert into 1000 into binary, and you have to do lap shifted by how many times? Suppose it's 10 times, so you could do 10 times lap shifted.
Okay.
So for 10 times or 5 times, so here 2 times, so you can write like this: 0 0 0 1 0 1 0. 2 times, that means you remove these 2 0 and add here 2 0. Understood? 5 times,
Yes.
that means remove here 5 things and add here 5 numbers, 5 0. So that is
Okay.
your output. One more shortcut, one equation is there. I will give you.
And why do we just add zeros only? Why not one? I mean, is
Mm,
there any condition or
rules. That is
okay,
the rules for this shift. We have to add only zeros.
okay.
So its compiler will add. We are not adding. So this is the understanding purpose. But once we will do k is equal to I left shifted by j, my output automatically will store 40 in my k. So its compiler itself it doing. Okay, so here I right shifted by j, that means 10 right shifted by 2 times. So here similar way. First time here this 0 will go here, this 1 will here, this 0 will here, this 1 will here, this 0 here, this 0 here, and here 1 0 will added. Second time this 1 will go here, this 0 will come here, this 1 will come here, this 0 will come here. So this 0 here and that 0 here. Here one added 0. So this is my output. So my input is number is 10, right shifted by 2 times my output here. So this part will be not usable more. So this is my output. So this is 2. Okay. So this is the most important things. We will see much more thing in the right shifted and left shifted. So I am giving you one equation for left shifted. We have one equation is what k is my result. So I will like this way. Result is equal to number is my 10 multiplication with 2 raised to how many times it shifts. So my number is 10 here. 10 into 2 raised to 2. So this is my output. This is shortcut equation. So you can find number into 2 raised to shift. So you will get your output. So that is any bigger number you will get your output. What is the using this equation for left shifted. For right shift, result is equal to number divide by 2 raised to shift. So here my number is 10 divided by 2 raised to 2. That means 10 divided by 4. The output is
So Yogin, in this case for the right shift, how will it work for maybe odd numbers? Because then they will not be directly divisible by 2 raised to whatever the shift it is.
yes, we can try. So we can take one odd number as 11 only. Okay, then 0 0 0 0. Otherwise, 11 divided by 2 raised to 2 is also output is my 2. 1 0 1 1. So here I will do remove this and 1 0 here, then this all the 0. Then also it will work like similar. Why it's work? Because in the right shift even number is considered here 1 and this 1 will remove.
Yes.
Make one program for the shift operator. Integer I is equal to 10, j is equal to 2, comma k is equal to I, left shifted by j, intf k is percentage d, comma k. Okay, I will again do k is equal to I right shifted by g. So here k Okay, right shifted. So here you can make data taking data from user and like this. Next most important program that we are every day using, and this is the most important for the interview. Three things. One is the how to set bit. Second one is the how to clear bit, and third one is the how to toggle or complement a bit. So what is the how to set bit? User will enter. So this is my input. Suppose I have number integer I is equal to 10 is my number. So user will enter the suppose user will I will make generic program. So user will enter any number and position. What is the meaning of position? I need to set particular bit of my number. So suppose user have entered 10 number and bit is second. So what is the binary of 10? 10 10 and bit is second. So this is my second bit. User want to set that particular bit in my number. So my output should be 1110. That means 14. So user want output is 14. Suppose user will enter the number by 14 only. So this is another example. Suppose user have entered the number 14 and position is 2. So my binary of 14 is 1110 and position is second. So this is 0th position, this is first and this is second position. And user want output to set this bit, and this bit is already set, so no need to do anything. So my output is again 14. If it is already set, then no need to do anything. If it is not set, then we have to set that particular bit. So this is the program first. So this is my mistake here. Output is 14. Yes. So we are discussing about how to set bit program. So what user will enter? User will enter number and particular position that he need to set. Suppose he need to set third position, he need to set fourth position, fifth position, 6, 17, 18, 32 till 31st. So 0 to 31st position. Any position user will enter and any number user will enter.
It is like or uh, operation, right? Like when we add two numbers,
Okay. So
ORing
my
of two
number
numbers.
1010 and I will do ORing of the number here 1 and my output here 00001. ORing with 0 or 1 is 1 and here 1 0. Yes, right. In this case also 0000111 and here 1 0000111. So in this case it is also working. So now you know you have to do ORing operation. That's the correct answer. But first things is we need to reach this particular position. Okay. So what I will do? I will do one lap shifted by position. So 1 lap shifted by 2 times. So I will reach here. This is my 1 is lap shifted by 2 times. Then I will do ORing with my original number. And I will store whatever the expression output in my number. So 1 lap shifted by position, that means my 1 will go 2 times here. So it will be here. And number ORing with, so this is my original number. It is doing ORing with 1 lap shifted by position. So I will reach here. So I will write this program here. 15.c. Write with me. So inside the integer, we need one number n. So I will write here return 0. So we need a number and position. So I will take integer number and position. So we want from the user. So I will write here printf enter number nf percentage d comma address of number and I will take printf enter position percentage d address of position. Then I will print here printf before number percentage d slash n comma number. Here I will write my logic. Number is equal to number ORing with 1 lap shifted by position. Then after I will print here after number. I will run this code. Suppose my number is 10 and position is 2. And suppose I will enter my number is 14 and position is 2. Then also it's 14. This is most important question for interview. How to set bit, how to clear or how to complement. Okay, write down this logic, that is the important. These all are the things you will do later also. Okay, next is the clear a bit. So similar way, we have number is 0001010. Suppose this bit I need to clear this particular. So what will be my output? Output will be like 0000010. 2. So this is my third number bit. Suppose it is already cleared. So this is my bit is already clear, second number. So 0000 and my input is I need to clear suppose second bit. So this is already clear. So my output should be 00001010. So 10. So how we will do this?
Shifting the zero by position and then ending it by the value.
No, that's not, because if we will
And
do ending with 0, so then this will also become 0. 1 ending with 0,
Okay.
and this will
and
also become. So I will write down number here again. Yes, now give ending with 1.
one.
Okay, I will try ending with 1. So this. Okay, So ending with 1, that means here all will be 0. Lap shifted by 1 we will do, and we will reach to this particular position ending with 1, then
This will not clear the
1.
bit.
Yes, exactly. We want to clear bit. So I erase this part.
We have to
First,
take the complement of that one.
exactly, we need to do the complement. So I will erase this part. So number is 000 and my number is 1010. First I will do reach here. So here 0001010, and first we will reach here. So that this is my number of one lap shifted by position. So I will reach here. I will do complement of that. So complement of that is 1111 0 1111. Now I will do ending with this operation. So ending 0 ending with 1 is first complement, then ending 0000. Here this bit will clear 0010. So my output is 2. In this case 00001010. Then I have to reach this position, and if it is already clear, then we no need to do anything. So first we will do complement of this number 1111. Here 1, here 0, and then 1 1. Then we will do ending operation. So this is the ending operation 00001. Here it is already clear 0 1 0. My output is 10. So my logic is like that way. Number is equal to number ending with complement of one lap shifted by position. Understood this logic?
Yes.
Okay. So in this program, I will comment this part and I will write down a logic here. Number is equal to number ending with complement of one lap shifted by position. So write down this logic only. Then I will move to the complement a bit. Okay. Next is the complement bit. What is the meaning of complement bit or toggle bit? If it is clear, then we need to set. If it is set, then we need to clear. Suppose user will enter the position second and number is 10. Then I will reach here. If it is already clear, then I need to set. If it is already set, so my output here is 1110 and 1010, and here this second position. If it is already, sorry, I will take third position. If it is already set, then we need to clear that bit. Then my output is 2, and here 14. Which bitwise operator? Ending, ORing, XORing?
Sorry.
Exactly, we need to do XOR here.
Mm.
So 0 XOR with 0 is 0. 0 XOR with 1 is 1. 0 XOR with 1 is 1. 0 XOR with 1 is 1. And here 0 XOR with 0 is 0. Here 1 XOR with 1 is 0. 0 XOR with 0 is 0. 1 XOR with 0 is 1. Like this way. So my output is 2. So my logic is number is equal to number XOR with one lap shifted by position. So I will write down logic here. number is equal to number XOR with 1 lap shifted by position. So understood these three logics. Why this is most important question for interview? Because yesterday I have mentioned we are using 32 bits for 32 different purposes. Suppose I want to do only one bit, that is the application is there, so I need to set that, clear that, complement that particular bit, and I don't need to change any other bits. Because of that reason we are using these logics in running life, day to day life, these three logics. And fourth logic is that I need to only check my bit is set or clear. I need to do nothing with that. How we will do this? So in result, I want my number is set or clear. I don't need to change my original number. I need to check only my number is particular bit is set or clear. So here this logic will come. In the case of clear, what we did a complement. Why we did a complement, not use AND? Suppose I will do ANDing. My number is 0001010 and my bit is this second number bit. And suppose I will do ANDing. So what is my output? One ending with 0 is also 0.
Zero.
One ending with 0 is 0. Here 0 0. Okay. Suppose my number is like this 0 0 0 0 10 10 and position is this one. So now
0 0 0 0 1 0
0.
0 0.
So I can say whenever I get output is 0, at that time my bit is clear. Whenever I get output of that particular position 1, at the time my bit is set. I can say 1 or its number is non-zero number I get. Any number you will get. I will not check that particular bit, but I will check my number is non-zero number. At that time I can say my bit is set. And if I get my number is 0, then I will say my bit is clear. So I will use this logic for that. Result is equal to number ending with 1 lap shifted by position. So in result, if I get 0, that means I can say it's my number is clear, and non-zero, then I can say number is set. So you can use this. So I will write down here result. So I want one variable is result here. Result is equal to number ending with 1 lap shifted by position. Understood this logic?
Yes.
So you have to use this logic inside the condition. So inside the condition, like that way you will use. So I will copy this logic. The output is equal to 0. Then my condition will become true. So I will print number is clear. Else number is set. Done. Any question?
No.